Sick. Um. Alrighty. We will study Numbers, Mobius proofs. You had a long Let's not dwell on that right now. I can't find it. So okay. No. Should have Discord out. Good old algebra. Given that 3z minus 2w is equal to that, and the conjugate is that, we find that z and w are that. I'm just gonna go backwards from equal. I think we'll study this tomorrow. Let's find complex polynomials. We will just. Okay. this first. We get 3x's I minus 2u plus minus 2vi, so minus 6. And so what I'm assuming here is we're going to take these real parts and form an equation. That's our first equation. We get 3y, minus 3y here, minus 2 here. So we get our second equation. Then we have this other equation, which we can still express as we're going to get 4 equations. We're going to get x, that's 1, sorry, I'm going to minus u onto this side because this is real part, right? Yeah. We're going to actually just bring everything to this side. So we get x minus u plus I minus I y is equal to minus 6. And so with this, we can create this equation. And then once again, we've got 2 equations. So it seems here that v is equal to y. That's the easiest to start. And so v is equal to y. We get 3y minus 2y is equal to minus 5. Right, we get minus 5y is equal to minus 5. And so, sorry about that. Minus 5 is equal to 1. Let's solve the same thing for v. So we also get v is equal to 1. Let's solve these guys. 3x minus 2u is equal to minus 16, and x minus u is equal to minus 6. So I can see here u, let's do x. X is equal to minus 6 plus u. Right, back into the equation. 3 times minus 6 plus u minus 2u is equal to minus 16. So we get minus 18 plus 3u minus 2u, so that's 1u. Minus 16 plus 18 on both sides. U is equal to 2. Once again, u. Because since u is equal to 2, x minus u, we would have minus 6. So x is equal to minus 4. And so we now have our roots. And we can compute z, because z is x plus iy, right? We're going to get minus 4 plus I. And for w, hopefully, you get 2 plus I. I hope it's right. If not, then I legit don't know. Fuck. Minus 2u minus v. So we get minus 3 minus 2 is equal to minus 5. Maybe it seems like we could have done like 3x minus 2u. That's the real part. Plus minus 3y minus 2vi is equal to minus 16 minus 5i. Will this be in a better form? Right? I don't know. Let's check actually. Z conjugate minus that conjugate is equal to minus 6. And so if we get Z conjugate, that's minus 4 minus I minus 2 minus I. We get minus 6 minus I plus I is equal to minus 6. Right, that looks right. Yeah, that looks right. Okay, let's try back into that equation. 3z minus 2w is equal to minus 16 minus 5i. 3 of that minus 2 of that minus 12 plus 3i minus 4 minus 2i is minus 16 minus 1 plus 1i. So this might be a minus 9. Who knows? Nope. Okay, let's try again. Given that 3z minus 2w there might be something going on with the step, like right here. But I'm assuming like oh, did I not do this? Definitely. That looks right. Okay, so I do have a problem right here. That's one mistake. It's fine. We might get a different answer. Minus u minus vi. So we get x minus u. Plus I to the negative y plus v. So, and right, we're just gonna start from here. V is equal to y. Helps. If we put v into y here, we get 3y minus 2y is equal to minus 5. Yep, so we get y minus 5. Yes, completely different answer then. And we also get 3, we get v minus 5. I think that might have been our mistake. Everything else is right. So let's just change that up. Let's just minus 5 to vi. Minus 5 to vi. There you go. Good. So just a small arithmetic problem. It's okay. Z is equal to 1 plus I. Then, oh, okay. Minus 1. Sorry, 1, 0. Oh, my bad. Oh, okay. My bad. Once again. Real of z squared is 1 plus height, so 2 pi. z cubed. If we remember Pascal's triangle, right? 1 cubed plus plus 3 times I plus 3 I plus I, which is 1 to the 9I plus minus 3, and then this I cubed is equal to I squared times I, so we get minus 1 times I, so we get minus I. What we do get here is these numbers. We get this. Let's just check. I hope. Yep. And then z to the 4th. 1, 4, 6, 4, 1 plus 4 to the 3rd. I plus 6 to the 2nd. I squared plus 4 to the I cubed plus I to the 4th. So that's equal to 1 plus, that's going to be an I, this is going to be another 1. That's minus 36, right? And then that's going to be another I, and then this is going to be a minus, this is going to be 2 minus 1. So we get, this is just a rule. Oh, they want me to find imaginary. Minus 34. All good. What? Guten Tag. Oh. I to the 4th. 4 cubed I. 6 squared I squared. Minus 36. Minus 1. Sorry, plus 1. 1 plus 1. Minus 36. Okay, we're just gonna do this way. Where was I? I squared plus 2I cubed plus I cubed. I to the 4th. I squared, I squared, I squared. 1 plus 4i. Okay. I don't know. That's fine. Plus 4i cubed. Plus 6i squared. Plus I to the so that's plus 1. That's an I, that's an I. This is a normal one. So it's 1 plus 1 minus 6. Okay, imaginary. Let's actually find the imaginary part of this. 4i, yep, 4i plus 4i cubed. This is minus I. So basically, 4i minus 4i is equal to 0. There is no part. Z cubed. This part and this part. We have 8i. Imaginary part is 8. And for z squared, we got 2 as our imaginary part. Did I fuck this up once again? Okay, that means my binomial theorems are just awful. What's going on? Oh, oh my god. It's to the A, not to go efficient. It's to the A. It's like A cubed plus 3 times 1 to the second I, you know? So that's 3 times 1, so that's right here. And this is 3 times 1 and then I to the second. Okay, that's just my fault. This is the imaginary part. This is the imaginary 3i minus I, 2i. Alrighty. We're going to be using Maple most of the time. So this is like practice. Complex numbers are a useful device to represent vectors. The vector 2, 3 plainly represented by the complex number 2 plus 3i. We may visualize this vector as emanating from the origin 0, 2, 3. Which this is the complex number z, reflection in the x-axis, and minus z is reflection in the y-axis. Okay, minus z, probably not then. Minus z. What? Yep. All right, this is 3. So this is z complement minus z is equal minus 2 minus. Okay, that's why. They go minus 2 minus 3. And so it's around the origin. This is the origin. minus of the complement is minus of this, so it's probably like right here. Okay, from z, right? So from z, this gets me that. This gets me that. This gets me that. So this itself is reflection. Okay, I'm gonna write reflection, right? And x. This is about origin. This is rotating 90 degrees. What? Okay, reflection in the y-axis. In y-axis, iz. So I'm guessing they flip the number around, right? Wait, let's just name this. This is minus z. This is minus z. And then now if we have iz is equal to I times minus 2 plus 3i. So minus 2i minus 3i squared. So that becomes 3. Yep, minus 2i. So if we do 3 minus 2i, let's actually throw this out. So this is iz. iz. It looks like this rotation. Nope. Is there anything else? So this is 90 degrees. iz is 90 degrees. Why is it 90? I thought it would be minus 90. Why does IZ make it turn 90 degrees, but not minus 90? Weird. I'll just save that actually. I also have to do numbers, which takes me to about 3 a.m. Okay, what is minus IZ? Oh, okay. That's why. IZ is equal to I of 2 plus 3I. 2I plus 3I. Minus 3 plus 2I. Cool. Minus IZ. An important use of complex conjugates is Q is equal to, I would use it a lot. A squared. Absolute value A squared. They've given us A plus B times A minus B. This is a handy thing to remember. This is a handy thing to remember. Okay? And what do you mean z squared? The real of z squared is equal a squared plus 2ab plus b squared. So minus b squared. Do you want me to write that? Will be the sum of the squares of these. Do you want me to write this? Oh, okay. Ah. Another handy tool. What are they saying here? This can be used to generate Pythagorean triples. Jesus Christ. PQR. That satisfy p squared plus q squared is equal to r squared. If z is equal to 2 plus I, then qz is 2 plus I squared. Sorry, squared modulus. Wait, could I do this? Sum of the squares. Sum of each one. Sum of each real. Quadrants. Intuitively, yes. Sum of each real part. 2 squared is 4. Fuck. The quadrants is the sum here squared. Sum. Eight. Fuck me in the face. 2 to 16. Nope. Let's think about this. If z is equal to 2 plus I, then the quadrants of z, just remember the quadrants of z as the just remember q of any z is equal to z times z. That's better for me. It's just too much in my brain right now. I'm just like tired. Got 11 hours before. Turn this up. Right. Oh, I get it. Sick. Okay. What they're saying is we can generate sets of 3, 4, 5, and 5, 12, 13, and so on by using quadrants of z. Oh, that's what they're saying. So we can always get real of z plus the imaginary part of z and q z, which is equal to 3, 4. Enter the following answers as a set of 3 numbers. So what they're just asking us to do is, what's z squared and what's the quadrants of z? Okay, so z squared is, okay, let's just do quadrants first. Because now we get 9 minus 2 squared to the I squared is 9 minus plus 4. And like automatically 5. That's okay. And then for 5 plus 3i, we're going to do z squared is equal to 25 plus 2 times 5 times 3i plus 3 squared I squared. 25 plus 30 minus 9. That's what we get. 16 plus 30i. The real part is 16. The imaginary part is 30. And the quadrant q of z is 5 squared minus 3 squared I squared. 25 plus 9. 36. 16, 30, 36. Come on. Fuck. Miscalculations. I've been doing that too fast. $34. Can you find this in this way a Pythagorean triple? All of those whose elements are larger than 100 with no common factors. So it seems like the imaginary part is going to be the thing holding us back. The real part. So let's take 100. Let's take 1. How do I do not common factor? Let's just do 100. Let's do 1,000 plus 1,000i. No, 500. Okay, let's use prime factorizations. 555. That's 5 times 11 times 10. Next, let's go to 5, 11, 5, 2. We're gonna get, and we want to take 3. We want to take something multiplied by 7, something multiplied by 3, squared, 7 squared. Looks good. So 49 times 9. 441. All right, let's do this. So let Z be 5, 5, 5 plus 441. Then Z squared is going to be 5, 5, 5 squared plus 2 times 441 555. It must be 2. Let's do 5 to the 5th. No, but that there's a 3 in there. To the 1357, right? Okay, we'll just multiply this by, no, we can't have 3. Can we do, let's do 7 to the 3rd, 7 to the 4th. 2041. Yeah, 2041. And let's do 5 times, yeah. Yep. So that's 25 times 5 times 5 times 11. 1375. Let's try that. Then 1357 squared plus 2 times 1375 times 2041 plus 2041 squared I squared. Shit. Looks like this number is going to be a negative number, so that's not good. That means we must flip it around. Okay. 2041 squared is 400. 65681. 4165681 plus 2 times 1375 times 2041. 5612750. I'm seeing this looks okay for now, but this number is gonna probably be divisible. This number is definitely divisible by 5. This number is probably divisible by 5. But how about we just do it first. 1, 8, 9, 6, 2, 5. I squared. Okay. But 2041 times 2041 is what? 4 million 1.9 million. Okay. So I want this number. This number minus this number. 189.0625. Okay. Sick. We got a 2, 2, 7, 5, 5, 6. Plus 5, 6, 1, 2, 7, 5, 5. Yeah, and then our quadrants is equal to 2041 plus 1375 times 2041 minus 1375. If we get 2041 squared minus plus 189.625. So that one plus 1375 times 137. Basically, we got 6 million. 6306. I hope that's right. Could be 2275056 5612750 605 6306. Unlucky. I want to ChatGPT that. At first glance, I'm thinking prime factorizations for the choice of a plus by. So what is the trick? It's Euclid's parametrization. So the constraint is m is larger than n, GCD is 1, and m is r. Okay, so we have now we've learned Archimedean yesterday, now we've learned Euclid's parametrization of Pythagorean triples, which is that GCD of m and n have to be 0, m minus n has to be odd, and that m is larger than n, and then find an m larger than that. Set 133. What did he pick here? 11n. Okay. 11 and 6. Let's take a number. So So they took 11.6. Chat took 11.6. Got 133.156. 205. Let's take 17 and 4. 17i plus 4i. Let's try it. Z squared is 17 squared plus 2 times 4 times 17 plus 4i. And the quadrants of Z is 17 squared plus 4 squared. So that gives us a 17 times 17. 2 plus 16. 305. Okay, and 17 squared minus 16. So, from 32 to 73, and this number 2 times 4 times 17, 8 times 17, 136. Let's see, 136, 273, and 305. Right off the bat, it doesn't look divisible. So let's try again. 136, 273, 305. Sick. New tool. Euclid. If a complex number alpha is a root of a quadratic equation, does it follow that the conjugate of alpha is also a root? Yes.
Hi, my name is Boris. You might remember me from such videos as how to find the area and normal to a parallelogram. Today, we're going to look at the following question. So we're asked to use properties of complex conjugates to show that if alpha is a complex...
By the way, content from 11 years ago. I don't like that it's teaching content from 11 years ago.
Root of this quadratic equation with the coefficients a, b, and c being real, and that's going to be very important later. We're asked to show that the conjugate of alpha is also a root. And then we're asked another question, a follow-up question, whether this actually generalizes to high degree polynomials. So in particular, is there something special about this being a quadratic equation? Would it work if there was a 3 here, for example? So we'll talk about that later. Okay, so the way we solve this problem is actually going back to the definition of what it means to be a root of an equation. And for alpha to be a root of this equation, it means that if we substitute alpha in, it satisfies the equation. Okay, and we also need to show now that basically if we replace alpha with alpha conjugate, we still satisfy this equation. So the way to introduce conjugates is to conjugate both sides of this equation. So what we get is A alpha squared plus B alpha plus C equals to 0, and we conjugate both sides. And now we're going to use the properties of complex conjugates to simplify this. So first of all, the conjugate of 0 is 0. The other property we're going to use is if we have sums of complex numbers and we take the conjugates, we can first take the conjugates and then take the sum. So in particular, if we have two complex numbers, z and w, and we take the conjugate, it's the same as first taking the conjugates and then adding them together. So if we apply this formula to this particular situation, we get A alpha squared conjugate plus B alpha conjugate plus C conjugate. And as I said, the conjugate of 0 is 0, so we just get 0. Okay, here we have a product of numbers. So we're going to use another property of complex conjugates, which states that if we have a product of two complex numbers and we need to take the conjugate, again, we can just do it one at a time. So first take the conjugates and then take the product. So if we apply this formula to this situation, we get the conjugate of A multiplied by the conjugate of alpha squared plus the conjugate of B multiplied by the conjugate of alpha plus the conjugate of C equals to 0. Okay, and now comes probably the most important part, and that's the fact that because A, B, and C are real, the conjugate of A, the conjugate of B, and the conjugate of C is just equal to A, B, and C. And this is only true because they're real numbers. In fact, this result is false if we don't assume that A, B, and C are real. Okay, so because A, B, C are real, we can now say that this is the same as A conjugate of alpha squared plus B conjugate of alpha plus C equals to 0. Okay, we're almost done. This is almost like substituting the conjugate of alpha into here, except here we have alpha squared conjugated, and we need the other way around. We need to say we want to have the conjugate of alpha squared. But luckily, again, there is another rule about complex numbers which we can use here, and that's the fact that if you take a complex number, raise it to some power, and take the conjugate, that's exactly the same as if you first conjugate and then raise it to this power. Okay, so now if we apply this rule to, we only need to apply it to this coefficient here, so then we get A conjugate of alpha squared plus B conjugate of alpha plus C equals to 0. And that's precisely what we get if we substitute the conjugate of alpha instead of x here, instead of substituting alpha, which by definition means the conjugate of alpha is the root of this equation. So we can say now, therefore, alpha conjugate is a root. Okay, so the next instead of x here, instead of substituting alpha, which by definition means the conjugate of alpha is the root of this equation. So we can say now, therefore, alpha conjugate is a root. Okay, so the next part of the question asks, does this generalize to higher degree polynomials? So was there anything special here that only worked because this was a 2? And I hope you can see that the answer is no. None of the rules here are used relied on the fact that this is a 2. We could have easily had ax cubed plus bx squared plus cx plus d equals to 0. And this proof would have worked exactly the same. Nothing would have changed. We would have used exactly the same rules in exactly the same order and come to exactly the same conclusion. So the answer to this question is, does this generalize? The answer is a big yes.
I'm asked about a harmonic quadratic equation. And yes, because let's say the equation has the roots W1 and W2, then because it's monic, right? The Z is going to be, the coefficient of Z is going to be 1. So it's going to be Z minus a root and then Z plus a root. I don't know what happens when the value of the root gets added together. Can be factored into Z squared minus ZW2 minus ZW1 plus W1 W2. So this and this is that, and that. So that's SZ. And that's R. Huh? Yeah, isn't that how they wrote it? Sorry, plus. This is minus Z times W2 plus W1. So it's actually minus S. Cool. Very sick. Good way to think about. So the sum of the roots, Z. Okay, so the sum of the roots is this number 7. And the product of roots is this number 6. Oh, okay. Fuck. Bro. That's the AC method. So this is the fundamental method that we've always learned on how to find roots, right? So the monic quadratic equation in Z with complex conjugate roots must be zero and equal. Oh, okay. So it just wants me to find the quadratic equation. Find the monic quad equation. Right? And so it's saying the sum of the roots. Six plus 4i. So this is W1 plus W2. plus 6 minus 4i. And so that cancels and we get 12. So that is our, basically our S. W1, W2 is, that's equal to 6 squared minus 4 squared I squared, which is 6 squared plus 4 squared. 36 plus 16 is 52. So we get the equation z squared minus 12 times z plus 52. Okay, that's fine. I don't even want. So W1 plus W2 is equal to minus 4. Okay, we see a minus sign in the real roots. That's completely fine. That's minus 8. Is equal to 4 squared plus 4 squared. So 32. So this is z squared plus 8 z plus 32. Perfect. So just remember, this is in the form negative. So this is the form. Be careful of negative z, because negative z, W1 plus W2 is the way, right? So negative z times negative 8 means plus 8z plus 32. I want this to be over. If a monic equation has real coefficients and one root, then that polynomial is, what do you mean? Am I supposed to write a I mean, if you give me one root, if given one root can find, could I just write quadratic? I don't even know, bro. Okay, just find the equation, bitch, is what it's telling me. Right? So this is W1. Then W2 is this. And so W1 plus W2 is minus 8. And then W1 times W2 is 4 squared plus 9 squared is 16 plus 81. 97. And so our equation is going to be that. Z squared plus 8 Z plus 97. I hope that's right. Let's see this. Minus 18. 936, 81 plus 16, also 97. Okay. Transform the general quadratic equation. First, we factor out a. Now add and subtract this. B over 2 times a squared. What? Hey. Not cool. I'm as sleepy as it is. Come on. There's a perfect square inside these brackets, namely the square of x plus that. So x plus that. So for the last step, we multiply through by. What are they multiplying? By a again. Nope. By 1 over a. Sorry, by a. This is one of the key derivations in mathematics, going back to the Persian mathematician Okay. So this is going from quadratic to vector form. So going from ax squared plus bx plus c into a times x minus h squared plus k. And so what we're going to do is factor a. Add and subtract 2a minus b over 2a squared. So this step is complete. The square. 3 is to form x plus the perfect square that we have created. Minus b over 2a squared plus c over a. 4 divide multiply by a and simplify. Where h is equal to b, pretty sure. Nope. I forgot. H is our perfect square, so H is that. It's this big ass number. But it's basically minus b over 2a. And c is that number. I don't even want to write that number. But that's our discriminant over 4a. Let's just do that. B squared. Minus 4a. Here we go. What do you mean? Okay, bruh. Okay, bruh. Okay. For AC, sorry about that. I was texting Albert. In fact, is a vertex of the parabola. As a consequence, the parabola with the equation can be rewritten as that, where h is, really want me to find it, minus this is a fun refresher. I love these. We've done a ton of this in high school. Okay, so that's equal to h. H is actually this. Yes. And K is the discriminant. Minus minus 100 minus 4 times 3 times 7 over 4 times 3 is minus 100 minus 12 times 7 is 84 over 12 is equal to minus 184 over 12. Right. And that, my friends, is 5 over 3. Kile mọi người, giống idol quốc can, chắc vậy. Trời ơi mà Kevin căng vậy. He looks huge, bro. Bro, why is his arms the size of my... Sorry. My bad.
It's not a cheap meal, but it tastes like one.
I'm really hungry.
Some viral hot pockets with a slight twist that come to
532 calories, 67 grams of protein.
Let's see.
Yeah, you can take that as a challenge with these chicken bacon buffalo hot pockets. Let's go ahead and make them. Go ahead and slap a neighbor and clock in. We're doing 3 pounds of chicken and some basic seasoning. Just a little garlic, salt, and pepper. Cook on high heat until internal temperature reaches. Not going to get you sick. Next, we're making a bodybuilder buffalo sauce. Lots of cottage cheese in there. Don't complain to me. Just make it and trust. Take your nice big chicken pan and set it off to the side. We're going to make the dough next. It's yogurt based. So follow all the directions. Mix it up well. Make a huge old
Maybe I should make that tomorrow. I should buy some Frank Hots. Cook some chicken out.
Go ahead and add all your toppings and make sure you follow, because we're going to have part 2 of It's Not a Cheat Meal, but it tastes like one. Like and follow through. It's not a cheat meal, but it tastes like one. Today we're making some viral hot.
Oh shit! I would devour like 2 of that though. $400 grams of fat-free cottage cheese. Should I put it in? Yeah, I could just put it in. Sick.
Lasagna, cottage cheese, layer it again, add some mozzarella and bacon. Take these weight loss lasagnas to work.
This looks like the ultimate meal prep. So let's try it so you don't have to, not take this worth your time, effort, and your calories. Alright, there is our finished product. How good does that look? I tried a bar recipe just like this one, and I tell you if it's worth your time, effort, and your calories. If that sounds good to you, drop me a follow. As usual, I mess with the ingredients in this one to make it higher in protein, so comment meal prep, and I'll send you the full recipe and the macros for the recipe. That's what it looks like on the inside. Alright, let's give it a go. I'm going to tell you right now, this whole thing is 500 calories and absolutely packed with protein. This is an amazing option for meal prep. Like, as I said from the start, this is the ultimate meal prep. Like, imagine bringing this to work, literally just putting a lid on here and opening that up at work. How easy is that? This literally took me 20 minutes to make. I put it in an air fryer, so it only took 20 minutes instead of a whole hour in the oven. The mixture took me about 15 minutes to make. This really is the perfect recipe for if you're busy, if you need to meal prep meals, and you need to prepare them for your week ahead. Strongly recommend you try this. And this is so filling. Like, that whole thing being 500 calories is a crazy amount of food. If you're someone on a fat loss journey,
Cho em sờ anh đi ạ. Cho anh sờ lại chị nhá. Ăn đùa gì đâu. Đúng rồi. Trong người anh mua á. Anh ra tập lâu chưa mà nhìn anh ngon đâu. Con đi hết chứ. Anh á, anh tập mình tập 6 năm rồi. Năm 2 hay là 6 thì bằng tuổi người yêu cũ mình. Bây giờ thì anh bỏ học rồi. Anh bỏ học đấy ạ? Đúng rồi, bỏ học từ năm nhất rồi. Anh cũng học để gọi là cho bố mẹ vui thôi. Ban đầu bố mẹ em không cho học đại học, xong rồi là em kiểu em quyết tâm là em xuống đây học, em tự đóng tiền học ấy. Cũng không thích kiểu xin tiền bố mẹ nhiều, cho nên là anh bỏ học, anh đi làm. Xong rồi bố mẹ anh không liên lạc cho anh luôn, kiểu giận mà. Đấy, xong rồi cắt đứt liên lạc thì thôi, cắt đứt viện trợ luôn. Ui ôi, cái thời gian này khó khăn lắm. Vừa đi làm PT phòng tập này. Nghe thu nhập giờ của anh ổn nhá. Đoán thử xem. Khoảng bao nhiêu? Em đoán tầm 20 triệu ấy. 20 triệu à? Vâng. Nhân 5 lên khoảng 100 triệu. 100 anh? Đúng rồi. 100 triệu một tháng? Đúng. 2K4? Đúng rồi. Anh cho em ít kinh nghiệm về tập gym với em cũng mới tập mà em tập nó không lên. Tập luyện dinh dưỡng nó đều phải dựa trên sự tính toán hết. Đó, và quan trọng ấy, mình sẽ phải kỷ luật và kiên trì. Thầy có biết top 1 trẻ đến Việt Nam là ai không? Top 1 trẻ? Là ai nhỉ? Em cũng không rõ. Về cứ search Thế Nguyên 2K4 là ra top 1 trẻ Việt Nam. Anh cho em sờ anh đi được. Sờ, ok, đây anh sờ đi. Được chưa? Cho anh sờ lại thử nhá. Trời ơi. Em sờ. Em thấy anh sờ của anh cảm giác sờ nó thích là sướng ạ, thích à? Đúng na đúng nịu à? Vâng. Hay anh em mình làm kèo vật tay không? Ui thôi anh trêu em vật đâu đi. Anh chúc chú 2 tay được không? Nào, 2, 3. Ui, ăn thua gì đâu. Này. Anh cho em xin thông tin này nhé. Em thực sự là em muốn thay đổi bản thân lắm ấy. Em muốn hỗ trợ người quyết tâm tập luyện thật sự thôi. Chắc
Sick. Good for him. This guy's massive. He's like massive on like a massive. Sorry. What's need bro? His arms don't look real, bro. Okay. Sorry, what happened? Minus 4 AC. Something's off. 12 times 7. 84. Sorry, this is plus. Okay. I'll just keep it like that then. It's not 4. Let's think about this for a second. Minus. So K is that and minus K. So in my formula, I might just write A x minus h squared plus K, like that. No, I mean, that's the form, but there's a lot of mix-up with how the form should be. And so if we make it that, where h, right, is equal to minus b over 2a, and k is, this should be like this, where k is equal to b squared minus 4ac over 4a. And so, once again, being careful with these terms is a good idea. Oh, there's something that we got wrong back here then. Z. Then it's this number. It's not R, right? Yeah. So it's this number. A Z squared plus B Z. If P of Z is equal to A Z squared plus B Z plus C is equal to the, oh, okay, this is the X minus H form. Fuck me, bro. X. What do you want me to? S Z minus S Z. I don't even know anymore. So we can find a number R satisfying that. Then we can solve Z in terms of A, and R as Z is equal to. This is Z minus Z. No, fuck. Oh, what is he saying? H. That's H. That's K. I'm really tired. Hey, I know that Z plus B over 2A squared is in the vector form X minus H squared, but I don't know what to write for that. And so when they wrote, hey, if we can find a number R satisfying R squared is equal to B squared minus 4AC, I also don't know why they're writing that. Wow, I'm really tired. It's 2. I mean, I don't need to do numbers yet. I could. What the okay, sure. So this is equal to this. Without the A, of course. Let's actually go back and get that number. Okay, and then they also multiplied by, so it's like that. Not even. No, 4a squared. No. Yeah, it did. Continued. Ax squared plus bx plus c is equal to sum x minus b on 2a squared minus 4 b squared minus 4ac over 4a is equal to 0. Therefore, a of x minus b 2a is equal to b ac over 4a. And so if we multiply both sides by 1 over a, right, that cancels. We get x is equal to that is equal to b squared minus 4ac over 4a squared, which we can simplify just a bit into 4ac over 2a squared. And so when you're looking at this form, right, we're getting oddly close to the quadratic formula. Hopefully you can recognize the usual quadratic formula here. If b squared minus 4ac is a positive real number, we will replace r with root. So we can find a real number r squared, so let's find b squared, then we can solve x. However, if b squared minus 1 is a negative real number, in fact, a general complex number, which will happen if a, b, and c are complex numbers, then there is no canonical, but we could find a value r satisfying that. And formula gives us the solution. So z is equal to the roots and then that. Okay. Very handy tool. The roots of a complex set quad could be defined as z is equal to b over 2a plus or minus r over 2a, where r squared is equal to b squared over 4ac. So if root b squared minus 4ac is then, so continue. If not, keep as r squared is equal to b squared minus 4ac. You can derive this further. Which is minus b over 2a plus r. Okay. And minus b minus r over 2a. So basically just expanding them over that. Okay, that's fine. Use this analysis to solve the complex quadratic equation. So we've been given that. And so we can just use this, right? So our A is that, our B is that, and our C is minus 3 minus I. Right? So the solution to this set is minus B plus or minus R over 2A. And so minus B is minus 2 plus or minus R. Complex for sure. So what do we do about that? Okay. Let's just put it in the square root for now. Let me just ask them. Hey, so when we're finding the R, right? So they've given us the analysis that we can solve Z using Khwarizmi's identity, and that Z is equal to minus B over 2A plus or minus R over 2A. And so if I was given a complex quadratic equation, would I be using R squared, or would I just use the root of B squared minus 4A and then include it in the solution as a set? If they understand what that means. You should actually try that one. The one that you... Wait, what? You should actually try another one. Try another one. A different one. Oh my god, then I have to find the... That's the root. Okay. So put the complex numbers in. then go through the let z bằng x plus iy stuff. What's b squared? 4 minus 4 times 1 plus I times minus 3 plus minus I over 2 times 1 plus I. So under the square root, we get 4 minus 4 minus I. Sorry. 4 minus 4 times minus 3 minus I minus 3I minus I squared. So that's plus 1. So we get minus 4 minus, that's minus 4I, and then that's, okay, that's 4 minus 4 times minus 2. Minus 4I. Okay. Root of 4 plus 8 plus, what's that? Plus 16I is equal to 12 plus 16I. Alright, so I'm given the root. Now find R such that R is equal to 12 plus 16I. Right? So let R be x plus IY. Then x plus IY squared is root. X squared plus xy I minus I squared. So xy minus y squared is equal to 12, and xy is equal to 16. Then we compute y is 16 over x. Put x squared minus 16 over x squared is equal to 12. x4 is equal to 16 squared over 12x squared. Bring that all over into one side. We get u squared minus 12u minus, what's 16 squared? 256 is equal to 0. And so now we solve u. That's a really big number, but we're going to double quadratic formula. So we're gonna get 12 plus or minus 12 squared minus 4 times, oh. No, it's okay. 1 times minus 2, 5, 6. Scare the shit out of me for a second. 2 times 1, so just 2. That's equal to 12 plus or minus 144 minus that big number, or plus 4 times 256. That's 1,024. Yep. So plus 144, and then that's 11168. So what's the squirt? What's the squirt of that? We get 34 something. It's okay. Okay. Over 2. And so we get 12 plus root 1168 over 2. And okay. I do want to break this term up so that we can simplify. But this means we can go 1168 divided by 2 by, let's go divided by 4. That's 292. So we brought 2 outside. And then 292 divided by 2 once again. So divide by 4. 292 divided by 4 is 73. So we get 4 root 73. We could pull out, 73 looks like a prime number to me. Yeah, that's fine. So we've got 4 root 73. Right? Yep. So we can pull something out. We can pull 2 out. Right, so now we got 6 plus or minus 2 root 73. So that's our, and then because x squared is u, so 6 plus or minus 2 root 73. That's perfect. Gets us to 36 plus or minus. Oh, we should have kept that. That's fine. But x, so we square that up. And we get 144 plus or minus 1168 over 4. So now we get, give me them numbers, 144 plus, if only I had maple. What's the other one? 144 minus 1168. Yeah. 256. Okay. Oh yeah. 1312 divided by 4 gives me 328. Okay. 2 numbers. I've got 2 roots. And I have to test the roots, right? I have to put this into y, that's 1, and then I'm assuming don't take the negative root. Hey, so my r, there's a positive and negative. What should I do about that? like specifically the x value. You know, one x value is a positive, one x value is a negative. So what should I do? Okay, it says just find one solution. I'm going to use this one. No, let's use this one. So an r is minus 256 minus 1 over 16i. Okay. So now we're going to go back at it. The set is, what's minus b? Minus 2 plus or minus minus 256 minus 1 over 16i. Yep, over 2 times 1. 1 plus I. Yeah. Okay, if my A is also complex, so the coefficient A is also complex, is that fine? If I'm guessing I don't need to do any manipulation. Sorry. Hey, so if my coefficient A is also complex number, I'm guessing I don't need to do any manipulation to that number, right? Okay, that's fine. Minus 258. Oh, fuck. Quy đồng lên. Right? We get minus 258. No, I can't even do that because that's wrong. Okay, I finally got another question about simplifying complex fractions. What's a cool way to do that? Oh my god, yeah, you're right. I'm a dumbass. Okay, Jesus. So that's 254. I'm almost done. Jesus Christ. I can't even finish numbers. I might finish numbers tomorrow. Minus 516 minus 516i minus 2 over 16i plus 2 over 16i squared over 8. 5 over 16 minus 2 over 16 minus 5 over 16i minus 2 over 16i over 8. I really want them to just solve this question now. I'm tired. It's going fucking fuck. Go for it, GPT. You can do this better than me. Better than I ever can. And so far, the solution's fine. Yo, chat. Please, chat. Am I? Whoa, am I? Yo, I was wrong the entire time. Jeez, I should have just done that. No, I'm not gonna. No, nope. Not today. Nope, that's wrong. Hey, it's wrong. Okay. Wait, find the root r of 12 plus 16i. Okay, I guess there was a mess up here. I was moving really fast. Don't even play with me. -2. The nth root of a number. How about this? It's 3 a.m. I'm gonna note in my notions tomorrow to Mobius revision from question 14. Yeah, from question 13 to 18. Okay. Tomorrow we're going to do some proofs. And we still haven't finished up to question 40 from 1081. And we do have
Pickled beef bowl. So here's the math. 1 cube, 2 grams. 1 red onion, 0 grams. 1 jalapeno, 0 grams. 1 tablespoon rice vinegar, 0 grams. 1 tablespoon lime juice, 0 grams. 1 tablespoon honey, 0 grams. 2 tablespoons soy sauce, 1 gram. 3 tablespoons non-fat Greek yogurt, 5 grams. 8 ounces, 93.7 lean ground beef, 47 grams. And that's 55 grams of protein. I put the rest. You can make this one yourself. Enjoy. The internet says there's no way I put 50 grams of protein into this 10-minute crunchy pickled beef bowl. So here's the math. All right, why you haven't joined the home studio movement 2.0 yet? Well, the internet says there's no way I put 55 grams of protein into this 10-minute crunchy pickled beef bowl. So here's the math. 1 cucumber, 2 grams. 1 red onion, 0 grams. 1 jalapeno, 0 grams. 1 tablespoon rice vinegar, 0 grams. 1 tablespoon lime juice, 0 grams. 1 tablespoon honey, 0 grams. 2 tablespoons soy sauce, 1 gram. 3 tablespoons non-fat Greek yogurt, 5 grams. 8 ounces, 93.7 grams beef, 47 grams. That's 55 grams of protein. I put the recipe below so you can make this one yourself. 1 red onion, 0 grams. 1 jalapeno, 0 grams. 1 tablespoon rice vinegar, 0 grams. 1 tablespoon lime juice, 0 grams.
So I just found out that Greek yogurt, the same Greek yogurt that can set you back €10, has an unlimited glitch. So here today, let's make low-fat Greek yogurt.
Is it in Vietnam?
If you're new to the gym and this is you've tried plans, you've tried discipline, the reason you keep failing that this whole serving of ice cream has 300 calories and a whopping 30. This is my full day of eating as a natural bodybuilder preparing for a modeling shoot in 5 days. Let's go. starting off the day super strong. They baked pancake blueberry and peanut butter. Now, personally, I like to leave the center a little bit undercooked and the edges very cakey, and then mix it all together. For modeling prep, I've dropped my carbohydrate intake by half, so I'm starting with most of my carbs first in the morning because I'm hitting a big leg day, sitting here on the way. After legs, great leg session. Look at my beautiful dry back. What a beautiful country. Not gonna lie, being on a low carb stage,
I miss Vietnam.
So quadratically, internet says there's
I miss Vietnam so much.
internet's
I miss Vietnam so much. Okay. This is what I'm going to do. I'm going to review this tomorrow. I'm going to go for it. Nope. Yep. Jesus Christ. So fucking long. Number. Way too long. So there's some pattern recognition here I should learn. Sorry, I can't even copy straight. I'm like really tired, guys. Holy crap, I'm tired. Like I don't even want to do this right now. Yeah, as long as I finish it, that's okay. Jesus. Yeah. Yeah. I mean, it was like a 3-hour sesh, but like, it's hard to like get the information in when they're not teaching us anything and we're learning most of it by ourselves. Square root minus square root 3 plus I over plus I over 2. Hope that works. I mean, I can definitely do this tomorrow, but like, I just need to get it done today. Just because school is a joke. Just give me my marks, man. Okay, good. It's okay. It's okay. Don't worry. Still wrong. Still wrong. I'm tired, bro. Different. And sick. I'm gonna look at this tomorrow. Okay, I will remember to be looking at this tomorrow. Don't submit the assignment, Jin. Don't be dumb. If you submit the assignment, you have to do it again. And I'd consider it lost. W 3 5 7 9 11 5 9 1. that 4 is 2, 4, 6, 8, 11. Why? We'll think about that. So yeah, that 4 is 0, 4, 7, 10. Completely wrong for these other two. That's okay. 4, 7, 10, 13. There's no 13. There's 1, 4, 7, 10, yeah. And 2, 5, 8, 11. So these two are wrong. Nope. Alrighty, guys. I'll just try to get it done as soon as possible. Thank you. Have a good night. Yeah, I gotta get a haircut. Okay, bye-bye.